Hello my dear students, I hope you are all doing well. My name is Benatang Patton and I welcome you all to the channel Classroom, where we learn together. So in today's class we will be learning about chemical equations. So this is a very important topic, and I find that most of the students, they struggle with chemical reactions and how to convert them to chemical equations. Now I do agree that it's not easy, but it is also not very difficult. Okay, so it is easy. All you need is you have to give time, and you need to be steady. Okay, you need to take your time and understand slowly. Okay, once you understand, you will never forget. So you need to be steady there, and you need to take your time and understand. So through this video, I'll try my very best to help you overcome that fear of facing chemical equations or facing chemical reactions. So chemistry is very easy if your basics are strong. And tell you what, my dear students, today's topic you were taught, okay, in class 7 also. Okay, you have learned about these topics in class 7 and class 8. So you are not new to this topic. But the thing is that during your class 7 and class 8, how did you study? You study just to pass your exam, isn't it? Nah? So you study just to pass your exam. So now you don't recollect that, because how did you study? Memorization. Blah, 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 blah. Nah? You just study like that. Everybody studies like this, isn't it? Just to pass the exam. So whether it's going inside your head or not, whether you're understanding or not, no. Okay, all you are interested is how to study and how to score good mark and how to pass the exam. So what you do is you memorize. And now the disadvantage of memorization is that once the exam is over, once the test is gone, gone, isn't it? Evaporation. Okay, it goes away from your head. Why? Because that's how memorization works. Memorization does not stay in your brain for long. Okay, it just stays for a brief amount of time. But when you understand things, your brain retains it for longer periods of time. That's why understanding is more important than memorization. Okay, so we will do away with our old method of memorization. From today onwards, we will just understand things. So take your time. Okay, take your time. Take your time, as much time as you want. You take your time. Okay, but make sure that you are progressive. So you should be progressing. Take your time at your own pace. You understand, and then you proceed in life. Okay, so you are responsible for yourself. So learn to take good care of yourself. Okay, you have to take good care of yourself. Every part of your body, everything. Okay, even your mind. Okay, your thinking, everything, you are responsible for it. So nobody else is gonna do it for you. Everybody can help. I'm here to help you, but at the end of the day, it is you who has to take care of yourself. So even understanding and even learning, okay, you have to start yourself. Okay, and at the same time, pray to God and seek His wisdom. With God's wisdom, you can. Okay, by yourself, you can do pretty much well, but without God's help, you will not achieve the things that you will not achieve to that level. Okay, with God's help, you can go to that level. So remember that you can do very well, but with God's help, you will achieve excellence. Remember, excellence is up there. Okay, excellence is not at your eye level. Excellence is up there. So aim for excellence, and excellence will only come from the divine help of God. So, well, this is not a religious class, but just sharing some important things which I want to tell you, that remember that you can do, I can do so much by myself, but I can do only very little without God's help. So remember to acknowledge God, and okay, believe, and you have a belief, keep upholding your belief, and then okay, follow that. Understood? So we will now go back to our lesson. So chemical equation. Sometimes it's good to go off track also. Okay, so sometimes time to time we go off track, but then we have to come back. Okay, we have to come back. So let's come back to our topic, which is chemical equations. So I was telling you about how to overcome the fear of chemistry. So in chemistry, we study chemical reactions and equations. So chemical equations, okay, how to represent chemical reactions and how to write chemical equations, very, very important. And in class 10, you need to know, okay, you need to know this. So there are three ways to represent a chemical reaction, okay. So one of them is called the word equation, the other one is called the skeletal equation, and the third one is called the balanced chemical equation. We will be learning those three today. So let us start by writing down the statement of a chemical reaction. So let me write down the statement, but you have to do one thing, which is grab a pen and notebook or a pencil, anything, okay, and then write down the notes, okay. This is going to be very important for you. So kindly take down these notes and you write down. Let this serve as a extra, okay, notes for you so that you can score better in your tests or your exam. All right. So don't just watch, but write, okay? Write it. That way you will remember better. So the statement for the chemical reaction is, it's from the textbook. So let us take an example from the textbook. There's a statement about magnesium given in the textbook. Let's try that. So the statement goes, magnesium ribbon burns in oxygen present in air with a dazzling white flame to produce a white powder called magnesium oxide. So this is the chemical reaction. Now we will first try with the first one, which is word equation. So let's try to convert this into word equation. So the first one is word equation. So let's try together converting this statement into word equation. So what is a word equation? A word equation, it is a representation, okay? It is a representation. It is a representation of the chemical reaction. So what I have just written above in the statement is a chemical reaction, okay. It is this story that you have written, that you have read, is it's about a chemical reaction which is happening. So it is a representation of the chemical reaction through words. Through words. So word equation. What is a word equation? A word equation is a representation of the chemical reaction through words. So how do we do this? Okay, so how do we do this? So the concept is, I'll give you the concept. So the concept is, you have to identify the elements and the compounds. So remember this is the concept. The concept is, you have to identify the elements and compounds as you read the statement. So let's read the statement and let's identify the elements and compounds present in this statement. So as we start reading, from the very first word itself, we come across an element, magnesium. So magnesium, okay. So we'll write magnesium because in word equation, we have to represent the chemical reaction through words. So what you have to do is, you have to write magnesium here in words. So you write magnesium. Simple, na? Magnesium. Magnesium ribbon burns in oxygen. So remember, we have to identify the elements and compounds. So the next element which I have encountered is oxygen. So we write here oxygen. Present in air. Now these statements, okay, we are not going to use them because these are just fill-ups. Okay, these are sentences which are used to construct the statement. So we are going to ignore them. We are only focusing on the names of the elements and compounds. Remember that this is the idea to learn. Okay, this is the idea to frame word equation. Okay, present in air with dazzling white flame. We don't need these things. To produce a white powder, we don't need this, called magnesium oxide. So this is a element or a compound. This is the compound. So we have to identify the compounds also. So we got the compound. So magnesium oxide. So this is it. So if we read the statement, we know that magnesium and oxygen are the reactants. So these two are reactants. So magnesium and oxygen, they undergo a chemical reaction. So these are the reactants. These are the reactants. And then we know that the reactants will undergo a chemical reaction and give us what? Very good. It will give us the product. Okay. So this is the product. So this is how we can represent a chemical reaction in word equation. Was it difficult? No, is it not? Okay. And then this thing may not be asked because, like I said, these are basics, okay, which you have been taught in class 7 and class 8. But you have to know this. Okay, you have to know this. So remember that this is how you represent a chemical reaction through word equation, where what we do is we represent the chemical reaction through words. So see, we are using words magnesium, okay, we are using words oxygen, and we are using words magnesium oxide. All right, now we will go to the next one. The next one is called the skeletal equation. So let's learn the skeletal equation. Let me write down here. Skeletal equation. So let us see. So how do we represent the chemical reaction in skeletal equation? So in skeletal equation, in this method, the reactants and the product are represented by their chemical symbols and formulae. So this is the definition of skeletal equation. In this method, which means in the skeletal equation method, the reactants and the products are represented by their chemical symbol and formulae. Means, so we have to represent the reactants and the product, okay, using their chemical symbol and formulae. Remember, elements have got their symbol. Okay, elements have got their symbol. I think I know that you are familiar with the names of the elements. So hydrogen, helium, lithium, beryllium, those series of elements, you are in class 10, so you should remember them. Okay, you should have it in your memory. And then you also know that those elements have got their symbol, isn't it? So we will represent the reactants. Okay, we will represent the reactants and the products by their symbol or by their formulae. Now remember, formulae is for compounds. Okay, compounds have formula, whereas elements have got their symbol. I repeat, compounds have their formula and elements, okay, have got their symbol. So here we will represent these reactants we'll be using the same statement only. So let's try to convert this, okay, this into into skeletal equation. So what we have to do is, this magnesium is written in words. Now in skeletal equation we will not write, okay, magnesium in words, rather we will convert this into its we will use the symbol of magnesium. So what is the symbol of magnesium? Anyone who knows the symbol of magnesium? Yes, very good. The symbol of magnesium is Mg. So magnesium we will write Mg. Plus will remain as it is, plus, and oxygen. So we have to write the symbol of oxygen. So oxygen ka symbol, what is the symbol of oxygen? Very good. Oxygen symbol is O2. This arrow will remain as it is. Now we will have to write the formula of magnesium oxide. Remember, this is a compound. Compounds have formula. Elements have symbol. I hope that's clear. So what is the formula of magnesium oxide? Anyone? Yes, raise your hand. If anyone who knows, raise your hand. All right, good. So yes, the formula of magnesium oxide is MgO. So it's MgO. That's it. This is it, my dear students. This is how we represent a chemical equation, a chemical reaction in skeletal equation. Very simple, isn't it? Okay, so it is this easy. All right. So now we'll go to the third one, which is balanced chemical equation. So let me erase this one. Okay, let me erase this one, and I think I can also remove the statement, isn't it? By now you know everything. So let me erase this and make more room for discussion. So okay, let me erase this also. So now we go to the third one, which is the balanced chemical equation. Number 3, balanced chemical equation. Before we discuss, let's write down what is a balanced chemical equation. So in this method, comma, the number of atoms on the reactant side are equal to the number of atoms on the product side. So in balanced chemical equation, in this method, the number of atoms on the reactant side are equal to the number of atoms on the product side. So we already have this one, so we will move ahead from here. So you know that these are the reactants and this is the product. So magnesium and oxygen are the reactants and magnesium oxide is the product. So in this method, we have to make the number of atoms present on the reactant side equal to the number of atoms on the product side. Now, why are we doing this? Why do we have to make sure that the number of atoms present on the reactant side should be equal to the number of atoms present on the product side? This is done so because there is a law called the law of conservation of mass, which is given by Antoine Lavoisier. So there is a law called law of conservation of mass. So there's a law called the law of conservation of mass. Conservation of mass. So this is the law given by Antoine Lavoisier. Given by Antoine Lavoisier, which says that mass of reactants should be equal to the mass of product. So the law of conservation of mass says that mass can neither be created nor be destroyed. Okay, it should always be balanced. Okay, mass has always to be balanced. The law of conservation of mass says that mass should always be conserved. There cannot be destruction of mass. Okay, but mass should always be conserved. Remember this law of conservation of mass tells us that mass has to be conserved. Okay, so we have to conserve mass. So following the law of conservation of mass, the number of atoms in the reactant site should be equal to the number of atoms in the product site. I repeat, following the law of conservation of mass, the number of atoms in the reactant site should be equal to the number of atoms in the product site. So let us write this here once. So Mg plus O2, which gives us MgO. So now let us balance this chemical equation. Balancing, okay, we will balance it. Now first, see, we are talking about the number of atoms. So let's start here. How many magnesium atoms are here? How many magnesium atoms are here? How much? Yes, 1, 2, 3. What is the correct answer? Is it 1 or 2 or 3? Yes, it's 1. Okay, it is 1. See, you don't see any number here, isn't it? That means 1. So 1, okay, 1 magnesium is here. Okay, so 1 magnesium on the reactant side. So this is the reactant side. This is the reactant side. So we have 1 magnesium on the reactant side. Now let's go to the product side. This is the product side. This is the product side. How many magnesiums are there in the product side? How many? How many? Yes, 1. Okay, 1. So how do I know it's 1? See, you don't see any number here, isn't it? You don't see any number here. So that means 1. So 1 magnesium here, 1 magnesium here. So magnesium is balanced. Okay, magnesium is balanced. So next we go to the oxygen. There are 2 reactants here. We are done with magnesium. Now we move to oxygen. So let's have a look at oxygen. How many oxygen atoms are here? How many oxygen atoms are here? How many? Okay, just look here. Okay, just look here. Forget about this now. Forget about this. And this is the product side. So don't look this side. Just focus here. Just focus here. Okay, focus here. How many oxygen atoms do you see? How many? 1, 2, 3, 4, 5. How many? How many are there? Yes, 2. There are 2. Which 2? This is the 2, isn't it? These 2 belongs to oxygen. So there are 2 oxygen atoms here. Understood? There are 2 oxygen atoms here. Now, let's go and check on the product side. How many oxygen atoms do you see? How many oxygen atoms do you see? Remember, these are together. Okay, magnesium and oxygen, they are together. They are a compound called magnesium oxide. They are together. So tell me, what number do you see? Do you see any number around oxygen? Do you see any number around oxygen? No, isn't it? No means 1. So this side we have 1 oxygen. This side we have 2 oxygen. Balance or imbalance? Imbalance, na? So it is like this. Okay, imbalance. If it is balanced, it should be like this. So 2 on the reactant side. So let's say my right side, my right hand is the reactant, and this is the left side. This is the product. So we have 2 atoms here. So 2 atoms means this becomes heavy, isn't it? So this goes down. This side of the plate is lighter, so it goes up like this. So this is how it is. Okay, so 2 oxygen, so heavier this side. Let's say I keep this marker here. So this side becomes heavier. Okay, so 2 here, isn't it? And this is empty, nothing is here, 1 only. So it's like this. This is imbalance. We have to make it balance. So we have to make it balance. So it's like this. Oxygen is imbalance. We have to make it balance. How do we make it balance? Remember, we have to add on the one which has got, which is less. So we have to add something here on my left side. Okay, this side, this is already 2. There are 2 oxygen atoms here. So don't put any more here. Put here the one which is empty. Nothing is here, isn't it? Put it here. Or the one which is less. Okay, so we'll put here. So what we do, we have to balance it. So when you put here, what happens? This will also get number, and then balancing will take place. Okay, we will learn more about this. So what we will do is we have to balance it. So let's balance it. So there is 2 oxygen here. There's only 1 oxygen here. So what do? I have to balance it. Now remember, my dear students, you are only allowed to write here. Okay, before the before the symbol or before the formula. I repeat, you are only allowed to write before the symbol or before the formula. You are only allowed to write before the symbol if it is an element or the formula if it is a compound. So if it is a symbol, you are to write before the symbol. So let's come back here. On the reactant side, we have the symbols. So you can write here before the symbol of magnesium, or you can write here before the symbol of oxygen. Or if we talk about formula, then for the formula also the same thing. You can only write here before the formula. Okay, nowhere else. So remember, we are not supposed to write anywhere else before the formula or before the symbol. So I see 2 oxygen here. Okay, this side is more. The reactant side has more oxygen. That means I have to balance it from the product side. So I have to make this side also 2. So what do? I put here 2. Remember, I have put here 2. So by putting 2 here, has it become balanced? Yes. There are 2 atoms of oxygen here. Now remember how these 2 works. Okay, remember these 2 belongs to both magnesium and oxygen. Remember these 2, they are a compound. They are always together. They are a compound, they are together. Whereas elements, they are free here. This element, this is magnesium, totally independent. This is oxygen, totally independent. They are elements, isn't it? So elements are independent, but compounds, they exist together. So magnesium and oxygen, they are together. So these two helps oxygen. Okay, these 2 helps oxygen. So oxygen atom has become 2. So these 2 belongs to oxygen, but remember that these 2 also belongs to magnesium. So now oxygen atom has become 2. Okay, so magnesium, the number of magnesium atoms has become 2. So that means this side, okay, we have to write 2 here also. Now we see, is it balanced or not? Let's check. How many magnesium here? 2 magnesium. How many magnesium here? 2 magnesium. Remember, these 2 belongs to magnesium. Okay, now these 2 belongs to oxygen also. So now how many oxygen this side? 2 oxygen. How many oxygen here? 2. Remember, these 2 belongs to oxygen. So for this, you don't need to use this one. Okay, only the oxygen being a diatomic molecule, it's written like this, O2. Okay, don't ever write oxygen like this. It is wrong to write oxygen like this. Oxygen will never exist like this. Oxygen is diatomic, so you have to always write like this. Remember this. Okay, so magnesium, the number of magnesium is 2 here. The number of magnesium is 2. Oxygen atom 2. Oxygen atom 2. All right. So this is what is called balanced chemical equation. Most of the students, they struggle with this balancing of chemical equation. Okay. So we will do more examples. Now we will discuss more about balancing chemical equation. Now one more thing before I forget. These numbers, okay, these numbers that we put here, these numbers that we are putting before the symbol or before the formula to balance the chemical equation, these are called as stoichiometric ratios. Okay, so these numbers are called as stoichiometric ratios. Sorry, not ratio but coefficient. Stoichiometric coefficient. STOICH. What is the spelling? CHIOMETRIC. Stoichiometric coefficients. So remember this, the numbers that we write before the compound or before the elements to balance the chemical reaction are known as stoichiometric coefficient. Very, very important. Okay, very, very important to know the names of these. Okay, these are called stoichiometric coefficients. I hope it's clear. All right, I'm about to erase this, so you can pause the video and copy it down. Okay, assuming that you have copied it down, let me erase it now, and we'll be discussing some more examples of balancing of chemical equation. So let me quickly erase this. So let's do some practice again. So practice questions. Now let us take one chemical reaction and learn balancing together. So iron plus water giving us Fe3O4 plus H2. Now let's learn how to balance chemical equation. Okay, so I'll give you the steps. So here you write down the steps to balancing a chemical equation. First step, step number one is identify the elements. This is how I teach in the class also. So the first step is identification of the elements. Now remember that we always start from left side and we go to the right side. Okay, from left hand to right hand. So we go like this, from left to right. All right, so what you do is here in this arrow we draw a line here. Now remember, before we proceed, remember to always keep a space here. Okay, keep a space here, keep a space here. See, I've kept some space here because the stoichiometric coefficients will be written here. I've kept a space here and I've kept a space here. So remember, you should keep a space here so that the stoichiometric coefficient, means the numbers which will help you bring the balancing, you will be writing them here. So always keep a space here. Understood? Now let's start balancing. The first step is to identify the elements. So we will start from here. Identify this element. This is an element, isn't it? So this is an element, this is iron. So you write down iron. Okay, then this one, this is a compound. Okay, this is the compound. This was element, now this is a compound. Together this is water. The name of this compound is called water. But in step one you have to identify the elements. So now you have to identify the elements present in the compound. So what are the elements present in this compound? It's hydrogen and oxygen. So you will write the elements hydrogen and oxygen. Don't write these two now. Okay, I'll tell you when to write. So in step one we don't write this. Ignore this. Okay, ignore these numbers in step one. All right, don't write them. I'll tell you when to write. We are in step one, which is we have to identify the elements. So we started from here. Iron has been identified. This is hydrogen, we have identified it. This is oxygen. Now the same elements will be found on this side. So this side is the product side. Okay, sometimes we call it as the left hand side. If we call this as the left hand side, we call this as the right hand side. I call it as the reactant side. Okay, these are the reactants. So this is the reactant side and this side is the product side. So the same elements will be found in the products also. So don't waste your time, just copy paste as it is. So write it as it is. This is iron, this is hydrogen, and this is oxygen. Following? Alright, good. Now we go to the step 2. What is step 2? Now we will give importance to these numbers. So now what we do is, you do the count the number of atoms. Count the number of atoms. So this is step number 2. Okay, count the number of atoms. Now let's start. We will start from here. How many iron atoms are here? Do you see any number here? No. No number means what? What will you write? Yes, who will tell me? Raise your hand. No number means what? Very good. 1. No number means 1. That means 1 iron. Okay, 1 iron. No number, no? So 1. Then we go to hydrogen. How many hydrogen do you see? How many? 1, 2, 2. Remember, this 2 strictly belongs to hydrogen. Okay, remember, these numbers that you see, this number belongs to hydrogen. Similarly, this 3 belongs to iron, this 4 belongs to oxygen, And to whom does this 2 belong to? To whom does this 2 belong to? Yes, hydrogen. Okay, so remember, these numbers belong to the symbol above them. Okay, above them, usually towards their left, not towards the right. It doesn't belong, this 3 doesn't belong to oxygen. Okay, it belongs to iron, towards the left. Okay, towards the left, remember that. So this 3 belongs to iron, and this 4 belongs to oxygen. Remember, this 4 doesn't belong to iron. Okay, this 4 belongs to oxygen only. Immediate, its immediate symbol towards the left. Okay, immediate symbol towards the left. Okay, not far left, immediate symbol towards the left. Remember that. So this 2 belongs to hydrogen. So how many hydrogen? 2 hydrogen. How many oxygen? Remember, this 2 doesn't belong to oxygen. This 2 belongs to hydrogen only. So how many oxygen? You don't see any number, na? That means 1. Okay, no, if we don't see any number, it means it is 1. So 1 oxygen. Then let's go to the product side. Now remember, do not copy paste, okay, like what you did in step 1. No, only in step 1 you can do copy pasting. For step 2, which is count the number of atoms, do not copy paste. Rather, you have to count the number of atoms. So let's start with iron. How many iron? How much? Correct, 3 iron. How many hydrogen? 2. Correct. How many oxygen? How many? Yes, 4 oxygen. Very good. So we have done step 2. Okay, we have done step 2. Now step 3. Okay, now step 3 is pause and balance. So in step 3, I want you to pause for a second, and when you pause, observe. Okay, so as you pause, you observe. Okay, pause, observe, and then balance. Now what are you observing? You are observing which needs balancing, which does not need balancing. Now let's start with iron. This side, on the reactant side, iron is 1. On the product side, there are 3 atoms. So the scale will be, if we compare this with the weighing scale which is found in the shops, how will it be? My left hand represents the products and my right hand represents the reactant. So 3 here. So 3 means it's heavier, and 1 is here. So it is like this. Balance or not? This is not balanced, imbalance. So iron is not balanced. So the one which is not balanced, we'll put X. Okay, we'll put X. Okay, we'll put X, which is not balanced. So that will balance later. The number of hydrogen here is, on the reactant side is 2. On the product side, it is again 2. Balance or not? Balance. Here it will be like this. So this is balance. Okay, so let's keep a tick. Okay, tick means it's already balanced. Okay, the number of oxygen on the reactant side is 1. The number of oxygen on the product side is 4. Balance or imbalance? Tell me, how many for balance? How many for imbalance? Balance or imbalance? Yes, yes, it's unbalanced. So this also is unbalanced. Okay, this is also unbalanced. Now you may be wondering why sir is writing X on this side. He could have written here also. Yes, I could have written here, but then I'm intentionally writing here because we will write the numbers on the lesser side. So we are going to put numbers here. Okay, here already the number is high. We don't touch this side. Okay, here the number is already high. This side is less. So in order to remember that I have to put the number here, I'm marking it X here. The same thing I did for iron. There is already 3 atoms of iron here. Already more. This side is less, isn't it? So we have to add here. So to remember, okay, to remember that I have to do here, I'm putting the X mark here. Understood? This is already balanced, so no problem. Okay, I can put it anywhere. So iron is unbalanced and oxygen is unbalanced. So now we will balance. But wait, is there a formula or is there a technique? Okay, like is there a technique to start? Because we have 2 elements which needs balancing. We have iron and we have oxygen who needs balancing. So is there a formula or a procedure which we should follow, okay, so that it becomes easier? Yes, there is a formula. So for balancing there are 2 ways. Okay, for balancing there are 2 methods. One is called oxygen and hydrogen first, and the other is called make it even. Okay, this is This is how I teach my students. So one is called the oxygen and hydrogen first. So oxygen, O for oxygen, and H for hydrogen. So oxygen and hydrogen first. This is one of the technique. And the other one is called the make it even. Make it even. So I'll teach you both. So what do I mean by oxygen and hydrogen first? By oxygen and hydrogen first, I mean if oxygen or hydrogen needs balancing, we will start with them first. Okay, so if oxygen or hydrogen needs balancing, we will start with them first. Okay, and make it even. This I will teach you in the next equation. Okay, here that even thing, the even thing. Okay, here the even thing we will not use it. Here we will use the first technique, which is make it. Okay, which is oxygen and hydrogen first. All right. So I see that oxygen and hydrogen. I see oxygen, hydrogen. Oxygen is here, hydrogen is here. Both oxygen and hydrogen are there. Okay, both oxygen and hydrogen are here. So with whom shall I start? So I will start with C. But look at hydrogen. Hydrogen is already balanced, isn't it? So that means I will start with now. Since hydrogen is already balanced, so I will have to balance oxygen first. Remember, I'm not balancing iron first. Okay, I'll start with oxygen first. Why? Because there's a formula where which is oxygen and hydrogen first. Always oxygen and hydrogen first. So we'll first balance oxygen and hydrogen first. Then only we'll proceed to the other elements. So I will start with oxygen. Hydrogen is already balanced, so we don't need to balance anymore. So let's balance oxygen. So here we have 4. So this side also we have to make it 4. Remember, we have to run after this number. Okay, this side the number is 4. This side only 1. So we have to make this 1 into 4. So we have to make it into 4. So we have to make it into 4. And remember, the relationship is multiplication. So 1, already 1 is there now. 1 into what number should you write here so that you get 4? 1 into what number should you write here so that the answer is 4? Correct. It's 4. So this 4, you will write it where? Where oxygen is here. Where is oxygen here? Oxygen is here, isn't it? So you will write this 4. You will write this 4 where? You will write it here. I told you now that there should be a space here. So this 4, you bring it up here and you write it here. Alright? So this 4, you brought it, okay, and you wrote it here. Why did you write this 4? Because you were balancing oxygen. Oxygen on the product side, it was 4. Here it was only 1. So we have to add and we have to bring a number here. We have to make it 4. So since the relationship is multiplication, 1 into what number will give you 4? It is 4. This 4 is written here. Remember, you are only allowed to write before the symbol or before the compound. Before the compound or before the symbol. So you have written this 4 here before the formula. Okay, before the formula. Now, because of this 4, now the number of hydrogen, the number of oxygen is balanced. We have 4 oxygen. Okay, this 4 belongs to oxygen. So now oxygen number has become balanced. So this has become balanced. So now we have 4 oxygen. Okay, remember this 4 belongs to both hydrogen. This 4 belongs to oxygen also. This 4 belongs to both the elements in this compound. Remember, water is a compound. So this 4 belongs to both the elements which make up the compound. If I write any number here, suppose I write here 7, then that means this 7 belongs to iron, this 7 belongs to oxygen also. That is what I want to tell you. Okay, so remember that. I'm just citing an example. So this 4 belongs to hydrogen also, this 4 belongs to oxygen also. Okay, so by writing this 4, oxygen has become balanced. Yes, so oxygen has become balanced. But wait, okay? We are not in a hurry, we'll do slowly. Now, by writing this 4, oxygen has become balanced, okay? But this 4 will also affect hydrogen, isn't it? This 4 will also affect hydrogen now. How will it affect hydrogen? See, this 4 will multiply with 2. So 4 2s are 8. That means the number of hydrogen atom has shot up to 8. So now this has become 8. This is what happens. At the beginning, okay, at the beginning, some elements may be balanced, but in the process of balancing, they become unbalanced again. So the number of hydrogen has shot up. How? It was 2 in the beginning. Now how did it become 8? Remember, this 4 belongs to hydrogen also. So 4 2s are 8. Understood? So this has become now 8. That means now hydrogen also has become imbalanced. So 8 here, 2 here only, so I'm gonna balance on this side. I have to put number here. Okay, now hydrogen has become unbalanced. Remember the rule, oxygen and hydrogen first. So now since hydrogen has become unbalanced, you work on hydrogen following the rule, oxygen and hydrogen first. Okay, so you work on hydrogen. So now the goal is to become 8, so we have to get 8 here. The relationship is multiplication. 2 into what number gives you 8? Correct, absolutely correct. 4. 2 fours are 8, isn't it? So this 4, where will you write? This 4 you will write where hydrogen is. Where is hydrogen? Here. So you are going to write here. So write here 4. So this number you will write here. So 4 twos are 8. Nah? 4 twos are 8. So 8 hydrogen here, 8 hydrogen here. Balance, balance. Okay, 8 hydrogen here. Now 4 twos are 8. So now this has become 8. 4 twos are 8. Okay, now finish. Oxygen and hydrogen first, done. All the oxygen and all the hydrogen are balanced. So now we can focus on iron also. So let's go and balance iron now. This side is 3, this side is 1. Okay, so iron is here. 1 here. Our goal is to make it into 3. You know the relationship is multiplication. So can you guess the number? What number should come here? 1 into what number gives you 3? Correct, it's 3. So where do I write this 3? Here. Do I write it here? Correct. So this 3, you will write it here. Now, let's check whether is it balanced or not. 3 iron. 3 iron. Balance? Yes. 4 twos are 8. 8 hydrogen. 4 twos are 8. 8 hydrogen. Balance? Balance. 4 oxygen. 4 oxygen. Balance? Balance. Voila. Clap for yourself. Why? Because you have learned balancing. Okay, so this is how balancing is done. Okay, and what are these numbers called? These numbers are called stoichiometric coefficients. Clear? Okay, now we will go to the next example. Okay, where I'll teach you this make it even method. Okay, so can I erase it? All right, so now we go to the next. So the next example that we will do, CH4 plus O2. Make sure that you keep a space, okay? And then CO2 plus H2O. Now, how do we start? We bring a line here. We write the reactant here. You can pause the video and you can do. I'm sure with that first example you have mastered it, so we can proceed. So now we follow the step 1. Identify the elements. We always start from left, so let's start from here. Okay, so I stumble upon this one. My first question to you is this an element or a compound? Is this an element or a compound? Yes, this is a compound. Since this is a compound, remember compounds are made up of 2 or more elements. So you have to know how to identify the elements present in this compound. So is this an element? Yes, this is which element? Having atomic number 6, which is it? Carbon, correct. So carbon, okay. Then we move ahead and we find this H. Is this an element? Yes, so H. Then we move ahead and then we encounter this one. This is oxygen. Very good. Next, so the same elements will be found here, so just copy paste it. CHO. All right, we are done with step 1. Now we go to step 2. Count the number of atoms. Let's count the number of atoms. How many carbon here? How many? Correct, 1. Nothing is here, isn't it? Nothing here. Here also no number. Here also nothing here, so 1. So 1. Okay, 1. Then how many hydrogen? Correct, 4. This 4 belongs. This 4 strictly belongs to hydrogen. So 4 hydrogen. Okay. How many oxygen? Yes. So easy, na? Why is there asking also? So easy. 2. 2 oxygen. Now next here. How many? How many carbon? Yes. 1. Isn't it 1? Okay, 1. So 1 carbon. Then how many oxygen? How many oxygen here? 2 here. And do you see oxygen here? Yes, isn't it? 2 from here, and there is 1 oxygen here. So how are we going to do it? Do you see this plus here? Yes. So 2 oxygen from here plus 1 oxygen from here. That means 2 plus 1. How many? 3. So 3 oxygen. Okay. And then how many hydrogen? How many? 2. Correct. Now step number 3, pause. And as you pause, you observe. Okay, you observe which needs balancing and which doesn't need balancing. So we will observe first. Carbon is balanced, so doesn't need balancing. What we do is we put a tick mark. Then we observe hydrogen needs balancing. So basically this side is less, so we'll be working here. So I put the cross mark here to remember that we have to balance hydrogen. And oxygen also needs balancing, isn't it? So this side is less, so maybe we'll have to put this side. So now we will balance. Now there are 2 methods. Okay, there are 2 methods. Oxygen, hydrogen first. Now oxygen and hydrogen first. So let's check, are our oxygen and hydrogen in this equation? Do they need balancing or are they balanced? Let's look at oxygen. They are not balanced. Let's look at hydrogen. Not balanced. So both oxygen and hydrogen are not balanced. So we will definitely be balancing them first. Okay, we will definitely be balancing them first. So both oxygen and hydrogen is balancing. So we can start with anyone. But wait. Now here I want to teach you this technique called the make it even. Now remember, this example is very important. This is a very, very important example. Okay, I want you to put a star mark here. Now see, why am I saying that this example is very important is because, see here, this you will see that oxygen is found in both the products. You have oxygen here also, and you have oxygen here also. Now this becomes a problem. Okay, this is a challenge. Unlike in the previous balancing where they were found in only one, either in one reactant or in one product. Unlike here, our oxygen, which is here, okay, our oxygen which needs balancing is found in both. So this creates a situation and we have to tackle this situation. So to overcome this situation, what we do is there's a technique called make it even. So what is this make it even? See, make it even technique means this. See here. So you pay attention to oxygen. Oxygen is found here also and oxygen is found here also. Yes or no? Yes. Oxygen is found here also. Oxygen is found here. Now, here in this product, the number of oxygen is 2. All right? The number of oxygen is 2. Is this even or odd? This is even. This is even, okay? Whereas if you go here, the number of oxygen here is, how much is the number of oxygen here? 1, is not. Is 1 even or odd? Odd. So we have to make this even. If you don't make this even and if you proceed with the first technique, which is oxygen hydrogen first, I'm telling you, okay, you can try, but I'm telling you that it will be very lengthy, and then you may get it, okay, but some of you may not get it. Some of you will just leave it like that. So I want to teach in such a way that even those who struggle with balancing will learn easily. Okay, for those of you who can do it easily, you will do it. Okay, this method is not for you. Okay, you can easily do it. Okay, you don't need this also. Actually, this is not even there. You can easily proceed with this one. This is not even there for you. But for those who struggle with balancing, this is especially for them. Okay, make it even, because I know you are going to run into this trouble. And I know my own students are there who struggle with this kind of chemical balancing. Okay, so this is for those students who get confused and who get stuck whenever this situation arises. And what is the situation here? The situation is when the atom which needs to be balanced is found in both the products or in both the reactants. Here, if you look on the reactant side, you will find oxygen only in one. Okay, you don't find oxygen here. It's only in one of the reactant. This is easy. Whereas if you look on the product side, you will find oxygen present in both the products. This is confusing, this is challenging. Okay, this is the, you can say this is the difficult level of balancing. So here, to help you, I have made this technique called make it even, which should be used only in this kind of cases. Okay, so make it even. So this side the oxygen number is already 2, it's even. Okay, here it is odd, nah? So let's make it even. But remember, you cannot write anything here. This is forbidden. You are not supposed to write anything here. You are allowed to write here, isn't it? You are allowed to write here. This space is available for us to write. You are not supposed to alter the formula. So don't ever write here, okay? So you are supposed to write here. So let's make this oxygen even, okay? So only one oxygen. So let's make it even. Let's put here 2. Put here 2, okay? Without any doubt, you put here 2. The moment you put here 2, the number of oxygen here becomes 2. So if I ask you how many oxygen here now, the number of oxygen is 2. 2 from here, 2 from here. I repeat, 2 oxygen here, 2 oxygen here. Okay, so the number of oxygen now becomes 4. So the number of oxygen has become 4. Remember, we are putting these 2 to make this number even. Okay, to make this oxygen even. This side, it was already even. We are putting these 2 to make this oxygen even. Okay, so 2 oxygen here, 2 oxygen here. The number has shot to 4. But remember, these 2 also belongs to hydrogen. So the number of hydrogen will also change. So this is 2 times 2, which is 4. So this hydrogen number has become 4. Clear? Now you see, hydrogen automatically balance, na? That's what I'm talking about. Okay, so hydrogen balance. Then what you need to do is, now here we have 4 oxygen, here we have 2 oxygen. So we have to balance the oxygen. This side is less, so we'll work here. So 2 oxygen here, oxygen is found here. So our goal is to make it 4. 2 is already there, so 2 into what number should you write here? So that on multiplying with this number will get you 4. The answer is yes, 2. So this 2 where you'll write? You'll write it here. So bring your 2 here. Okay, then the number becomes 4. So 2 2s are 4. 2 oxygen here, 2 here, 4. Now let's check, is it balanced? Well, carbon though is balanced, isn't it? So now let's see. So 1 carbon, balance. 4 hydrogen, balance. 4 oxygen, 2 here and 2 here, 4 oxygen. Balance, yes, balance. So this is it, my dear students. This is how you balance chemical equations. In the next class, we will be doing more. In the next video, we will be discussing more. But in this video, I wanted to teach you this. And this is very important. The second one, this chemical balancing is very important. Okay, I cannot emphasize more. Okay, but I'm telling you again and again that this is the tricky part of balancing chemical equation. So I want you to follow this technique whenever you come across such type of questions, so that you don't panic. Okay, don't panic, just make it even and start, and very easily you'll get it. Okay, so in the next video we will continue with more balancing of chemical equation. Okay, so before we end the video, I have a question for you, and I want you to give the answer in the comment section. So the question is, yes, what is the name of the law followed in balancing of chemical equations or equation? Kindly give the answer in the comment box. So you kindly comment the answer in the comment box. Your participation will be very much appreciated. So thank you, my dear students, for tuning in and watching the video. In today's class, we have learned about chemical equations. We have learned the 3 ways by which we can represent the chemical equation. One is word equation, the second is skeletal equation, and the third one is balancing of chemical equation, and we have done 2 examples on balancing of chemical equation. And with that, we end up today's session. In the next class, we'll continue with more, so stay tuned and don't forget to watch the next video. God bless you all.